Om Namah Shivaya. Hi friends, how are you? In this video we are going to learn about endocrine functions of hypothalamus. The hypothalamus controls many homeostatic functions: visceral and behavioral function, sleep wakefulness, circadian rhythm, reproductive function. Major hypothalamic functions are listed as follows. Okay, see one by one. Endocrine functions, autonomic function, circadian rhythm, temperature regulation, regulation of food intake, regulation of water intake, reproductive functions, and influence on emotion and role in sleep, immunological functions. Okay, we see one by one. First, endocrine function. Hypothalamus control endocrine functions via its connection with pituitary gland. Hypothalamus control endocrine function via its connection with pituitary gland. It controls both anterior and posterior pituitary function. Hypothalamus is connected with anterior pituitary through portal hypophyseal vessels. Remember guys, anterior pituitary through vessels. Okay, remember these vessels. Anterior pituitary through portal hypophyseal vessels and with posterior pituitary via hypothalamo-hypophyseal tract. Anterior pituitary through vessels and posterior pituitary through tract. Okay. First, coming to the control of anterior pituitary functions. Hypothalamus controls secretion of all anterior pituitary hormones by secreting various releasing and inhibiting hormones. Hypothalamus controls secretion of all anterior pituitary hormones and by secreting various releasing and inhibiting hormones. These hormones are synthesized in the hypothalamus and transported to the median eminence. These hormones are synthesized in the hypothalamus and transported to the median eminence. From there, they enter the portal plexus of superior hypophyseal artery. From there, they enter the portal plexus of superior hypophyseal artery. From there, these hormones travel in the long portal vessels. From there, these hormones travel in the long portal vessels to reach the anterior pituitary. The main releasing and inhibiting hormones are corticotropin releasing hormone that regulates adrenocorticotropic hormone secretion. Corticotropin releasing hormone that regulates adrenocorticotropic hormone secretion. Growth hormone releasing hormone GRH that controls growth hormone secretion. Next, somatostatin that inhibits growth hormone, thyroid stimulating hormone and prolactin secretion. Somatostatin that inhibits growth hormone, thyroid stimulating hormone and prolactin secretion. Thyrotropin releasing hormone that stimulates thyroid stimulating hormone secretion. Prolactin releasing hormone and prolactin inhibiting hormone and gonadotropin releasing hormone that stimulates luteinizing hormone and follicular stimulating hormone secretion. Okay, many of these hormones act as neurotransmitters in cerebral cortex and limbic system, and few of them also have peripheral actions. Many of these hormones act as neurotransmitters. In cerebral cortex and limbic system, and few of them have peripheral actions. Next, coming to the control of posterior pituitary actions. Hypothalamus secretes two hormones, antidiuretic hormone and oxytocin. Antidiuretic hormone also called as vasopressin. These hormones, that means antidiuretic hormone and oxytocin, are synthesized by the neurons of supraoptic and paraventricular nuclei of hypothalamus. These hormones are synthesized by neurons of supraoptic and paraventricular nuclei of hypothalamus. They are transported along their axons. These axons are hypothalamo-hypophyseal tract to the posterior pituitary, where they are stored and released into circulation at the time of need. See once again, control of posterior pituitary function. Hypothalamus secretes two hormones, antidiuretic hormone and oxytocin. Antidiuretic hormone also called as vasopressin. These hormones are synthesized by neurons of supraoptic and paraventricular nuclei of hypothalamus. Remember this, supraoptic and paraventricular nuclei of hypothalamus that synthesize antidiuretic hormone and oxytocin. They are transported along their axons. These axons are hypothalamo-hypophyseal tract to the posterior pituitary. In posterior pituitary, they are stored and released into circulation at the time of need. Okay guys, we completed endocrine function of hypothalamus. In next video we are going to learn about autonomic functions of hypothalamus. Okay, if you like this video, like, share and subscribe. Thank you.